Okay, we have two more functional groups left to discuss. So first, esters. Esters have the functional group C double bond O, single bond O, R, where R could be another alkyl group, so another carbon group or carbon chain. Esters are formed by the combination of an acid and an alcohol by eliminating one molecule of water, so think dehydration synthesis. They're usually pleasant smelling compounds, such as natural oils and essence. So I take these two here. So this compound plus this compound. So I have a carboxylic acid here, COOH, and an alcohol here. And if I remove a water, so how am I going to remove that water? I'm going to remove this alcohol group and this, or this H. Actually, the way it happens is we remove this H and this alcohol group. And we're left then with C double bond O connecting this first CH3 and the second CH3. Okay. This is known as methyl acetate. And if I add an ethyl group at the end, it's ethyl acetate, and so on. An ether has an oxygen single bonded sandwiched between two carbon groups. So if I have an oxygen in the middle of two methyl groups, methyl is one carbon, right? So if I have one oxygen in between two methyl groups, I call that dimethyl ether. If I have two ethyl groups, ethyl meaning two carbons, so I have an oxygen in the middle of both of those, I'd call that diethyl ether. Ethers can also form cyclic structures like tetrahydrofuran shown. Ethers are highly flammable and used as solvents in organic synthesis. Here's a summary of all of the groups that contain a carbon-oxygen double bond, the carbonyl groups. An aldehyde, of course, has the carbon on the terminal, the double bond oxygen on the terminal carbon, so we have an H there. Ketones have the double bond oxygen somewhere in between two other carbon-containing groups. A carboxylic acid has the double bonded oxygen with an OH group, and an ester has a double bonded oxygen and a single bonded oxygen on the same carbon, and as we said, is produced by dehydration synthesis.